Thank you. As is usual about this time of day and when you've had all the tsunami talks, everyone's said it, so this is going to be a very short talk if I'm lucky. I will be covering a few of my favourite topics, and I won't be going into great detail, but just listening to some of the talks we've had over the last two sessions, the advances being made are fantastic and is absolutely brilliant. So there's very little I can really add other than I say, just offering a couple of little things, so entertain you for a bit. The interesting thing is that when some of the oldies were doing work on tsunamis sort of prior to, let's say, 1998 even, certainly prior to 2004, we were scrabbling around trying to entertain people and tell them what a tsunami was like, and we were using things like these black and white photographs. This is from Hilo, and saying, by the way, this is what a tsunami looks like and this is what people are doing when, tsunami happens. Very difficult to engage people with black and white photographs or some colour ones from Alaska and things like that. And so we've now moved on and we're doing remarkably well. I just have this brief bit from the 2011.
Homes alongside the river. In Sendai City, this is, in Miyagi Prefecture.
Right.
The tsunami has...
Shush. Be quiet. How do I get out of that?
In Goff.
Oh, no. How do I move on? Could someone move me on? Where do I go? About there? Thank you. So, we have certainly moved on. We have done a great job. Technology is a wonderful thing, and it's driving us. You can see from almost all the talks that have been presented about how technology is pushing us forward. Here we have, the first online, live, helicopter, high-definition video footage of a tsunami. This is absolutely stunning advance just from that alone. Absolutely incredible. This, in a sense, has driven international collaboration. We've been involved in 2011 from all different countries. 2004, lots of different countries getting involved, lots of new people getting involved. And that international collaboration is fantastic because it's generating ideas coming from so many different perspectives, and that's brilliant. And of course, the curiosity is driving us. I was just listening to that last talk about underwater, offshore tsunamis, really great stuff. How do we go about getting this stuff out of the ground, for example? Absolutely fantastic stuff being done. And a recognition of these rapid changes. I stole this slide from Bruce Jaffe, who will forgive me, I trust, just as an example of how rapidly work on paleo stuff, just paleo stuff alone, has gone through the roof, essentially. Since about 2004 onwards, we see a massive increase in the number of publications being produced in paleo work. Now, if you look at the entire discipline, I had to put a man running uphill there for some reason. We've got nearly 14,000 publications on tsunamis that I culled from Scopus, and that's clearly an underestimate of the number that there really are. But you look, following 2004, an order of magnitude increase. This is how significant the work has become and how rapidly we have advanced since 2004. And then that level has been sustained, unfortunately, by ongoing tsunamis, 2009 in Samoa, 2010 in Chile, 2011 in Japan. These things are being sustained. That level of publication, the level of research is now absolutely phenomenal. And not surprisingly, we're making a lot of great significant advances, which I will not be talking about because everyone's talked about them already. I will just, in my abstract, I basically said, look, there's a lot of things that have been done. We're making great advances, even on simple things like either end of the grain size spectrum. Boulders, mud. Two things very dear to my heart, which I'll come to in a moment. But equally, the advances in geochemistry, something else that's dear to my heart, and she's sitting next to me right now. Also, other things like microfossils. We're doing fantastically. We're not just identifying a diatom or a foram. It's where it came from, how it's been smashed up, how it's been broken down over time, etc., etc., etc. And a lot of non-geological data. And again, this is another area that's quite dear to me in the sense of we want to find other evidence. It's not just the geology. We're not all geologists anymore. There's other things out there. And again, I'll come to that in a second. So I'm just going to have a couple of favourite sort of chit-chats about things that have changed. In the late 1900s, so the 1990s, there was a lot of stuff about boulders, particularly in our neck of the woods in New South Wales in Australia. So we've moved on from that, somewhat unreliable suggestions of mega tsunamis happening about once every 500 years. Here we have an Aboriginal tyre in a 500-year-old deposit, apparently. I didn't realise tyres were made then, but that's okay. We've moved on, and here is a great example. I just picked one by Kazu Goto from the Ryukyu Islands, and here he's managed to differentiate between both storm deposits and tsunami deposits using just boulders. This is really, really cool stuff, and you can see as we move on, tsunami boulders are going to become far better understood, and we'll be able to say that is indeed a tsunami boulder, it's not a storm. And we're going to get a much better use out of that coarser end of the size fraction. Very important stuff. Hey, move. Thank you. And now we come to the bit that I really like, which is mud, the fine end of the sediment fraction, if you wish. We progressed a lot. I can remember when we did our first work in the early 90s in New Zealand, and we found paleo-tsunami mud. We didn't know it was paleo-tsunami mud at the time, but we found it, and there it is sitting there quietly enjoying itself. And so it's been interesting to see the progression over the years. In 2004, here we see a massive great swath of mud being deposited by the 2004 tsunami. We didn't really think too much about it then, other than the fact there was a lot of it. In 2009, we see massive great layer of mud and organics sitting over a very thin, boring sand layer related to that deposit. And then we come into 2011. Now, 2011 is in a sense where mud has probably hit the big time, in the sense of people have suddenly started to recognize that the sand deposit only goes so far. The coarse sediment only goes to a certain point. In this case, about 60% of the distance inland, and then you start kicking into the mud-dominated stuff, and the mud-dominated stuff gets up to about 4.75 kilometres inland on this particular transect, compared to the sand that gets to about 2.8. So the mud has added this huge additional line of information that a lot of people are starting to pursue now more vigorously, which is great, recognizing that there is something in there that's going to start telling us about how big some of these earlier events actually were. And if you then start looking at, for example, the Jogan deposit, the Jogan deposit can be traced from the present-day shoreline, I just put it, about 4 kilometres inland using the sand, and we have moved inland at least another kilometre already, and we haven't run out of the mud yet. So this is really kind of interesting stuff, and it's just mud. It's just one of those little advances that we've let slip because a sand deposit's very easy to find, and a boulder's very easy to find, and the mud has kind of quietly gone under the radar until very recently. And I come on to my favourite of geochemistry, you know, the days when we could just say, okay, we found a marine signal related to a deposit. Here it is. In this particular instance, we got some sulfur, some strontium, some sodium, and then we got titanium as some indication of a high energy event that's come from the sea. Great, fantastic. Anyone can do that. That's very simple. We've now moved on to the kind of thing that says, okay, the mud takes us a long way inland from the sand. That's one hell of an advance. Well, now let's throw in the geochemistry. That takes us even further inland, because once the mud runs out, the water keeps going. And when the water runs out, the signal of the salt water stops. It stops here for the 2011. So we've now got, not only do we have mud to tell us an extra bit, we've got the geochemistry as well. And these are really exciting advances when it comes around to understanding how big and how often these events have occurred in the past. So there's this seemingly endless list of proxies. I mean, it's been nice to see a couple of people citing the paper I wrote in 2012 and Catherine's paper in 2011, and you keep going back through times. We've seen proxies being added to the list as we go on. I haven't even mentioned microfossils because I haven't got time to talk about them, but they're a favourite of mine. I haven't mentioned AMS, I haven't mentioned biomarkers, I haven't mentioned some of the really new cool stuff that people have mentioned today. But some of the things that are, let's say, the non-geology ones that I kind of find exciting, geomorphology, and I've noticed I made a great mistake with this one. I said it was the 2001. I think it was the 2011 in Japan. I think it wasn't 2001. But here we see a geomorphological expression of that tsunami. We have pedestals which have been eroded. The dune has been basically destroyed. Well, if you go to sand-poor environments on coastlines which have been inundated, you can find these pedestal features 500-600 years old. They're still sitting there in the landscape, telling us that, by the way, you should have a look in here somewhere. There'll be a geological record for you to see. Archaeologically, we saw what the 2011 did to people, and we can go back in time into the archaeological record and see exactly what prehistoric events did. Here we have an old oven overlain by the gravelly, sandy tsunami deposit. Here we have a burial. All the loose sand that the people dug through to bury that person has been picked up by the tsunami and carried inland, and you're just left with the skeleton sitting there on the surface. These are things that are in the archaeological record that we avoid and we don't look at our peril, because there's a lot of information in it. And then you come to one of my faves, which is the anthropological stuff. This is a picture of a sea monster, which in New Zealand is known as a taniwha, eating a human. This is the old picture books that we get today and show to our kids and things. Well, this is on the top of a cave in New Zealand. It's talking about Tapuareru Utu Utu, which was a nasty sea monster sent by the god of the sea. Actually, it was again because a woman did something wrong, and so it was basically seeking revenge for this woman doing something wrong, and it destroyed the entire village. Absolutely cool stuff. Why aren't we using that kind of information? It's really neat. Okay, and I'll just finish with this. There are some serious problems that we have. One is that there is no single silver bullet. We have to look at more than one proxy or two. Many of these produce different signals at different sites. That's kind of a bit of an issue. They're not all available at one site, although amusingly no one's actually tried to find out, because we all like going for our favourite ones. Oh, I'll do grain size, I'll do microfossils, or I'll do diatoms, I can't do forams, I'll do pollen, maybe I'll do something like a bit of geochemistry, and that'll be it. Well, then the last count in the last paper we wrote were 31 proxies, and I've only mentioned 4, which seem to be the kind of popular ones. So we need to get out there and do a lot more. We need to do better work. And I'll let you continue reading that. The point near the bottom, which I think is very important, is the devil is in the detail, and it was mentioned in the last talk. We've got to get into the detail of the proxies. We're doing very good. The advances we've made with diatoms and grain size, just looking at some of the stuff today, is fantastic. We need to do that with every deposit, every single piece of work, or else all we're doing is effectively stamp collecting. We're saying, okay, well, I went out, I found a sand layer, it kind of looks like a tsunami, or it's possibly one of those, I did some diatoms, it's come from the sea, great. I'll call it a possible tsunami. There's a subduction zone offshore, so it's probably a tsunami. That's not good enough. We've got enough information now to be able to say this is. It's not a possible, it's not a probable, we have to get to making these definites, or else a lot of the work we're doing is actually not particularly useful for tsunami hazard and risk, because we're not being definitive about what we're finding. And we've got enough information now to go out and do that. And on that note, I will leave you. Thank you.